I do good for good's sake, with no thought of compensation. And I've evolved to the point where I don't care a thing about getting rewards.
Okay, so thank you everyone to join this session. So this is the last one, the last session in this marketplace. So, so in Chinese it means the 压轴. So it means the most important one is comes the last. Okay, so here comes a quick introduction from ourselves. So we are working for the VMware integration of integrated OpenStack team, and so these are our three engineers from Beijing, and in this session we'll share our experience and plans. While we are moving our overall OpenStack control plane from virtual machines to Kubernetes. Okay. So this is a brief agenda. We will quick go through what VIO is and what's the motivation, and then we'll go through what issues we met and how we solve them. So what is VMware integrated OpenStack? In general, it's a very quick installation tool and OpenStack distribution, which we can deploy OpenStack on vSphere infrastructure. So if you have already a vSphere customer, it's very easy to deploy a HA-enabled OpenStack deployment. You may need just 1 hour to deploy to bring up the overall OpenStack cluster, and everything is ready. So we are also leveraging the vSphere and other VMware products like DRS and vMotion for Nova, which means we can live migrate VMs from one host to another host. We are also can utilize NSST, which is a vSphere software-defined network tool. We can also use vSAN for Cinder and Glance. And in day 2, we can easily scale out when there are more workloads, and we can integrate with other OpenStack, other VMware products. So this is a VIO version 5. So a typical VIO deployment, which combined, we can see we have 10 VMs, virtual machines. The first one is our OpenStack management server. When we deploy it, you can only have this one, and we have a UI to have user to import several simple parameters like IP address, FQD, and NTP server. Then for about 1 hour, we can bring up the overall OpenStack cluster and overall we have 10 VMs. So we have two load balancer, and 3 database nodes, which is working as active and standby. We have 2 controllers. We can installed all the OpenStack services, and we have computer drives, which means every computer resource we have a computer drive VMs. So this is a typical via 5 control plane, which have everything is running on virtual machines. So why we are moving to Kubernetes? So first of all, Kubernetes is very popular recently because everyone is talking about the Kubernetes. It's small footprint, and we can have it faster day 1 and day 2 operations like provision, scaling out, and provide a more easy way to scale out the services. And Kubernetes can help us to do easy upgrade or patch. So this is all the motivations. And so from late last year, we are planning to move the overall control plane from VMs to Kubernetes. So by now we only have 4 VMs, one master and 3 controller. Actually, it's a Kubernetes cluster, and we are running everything as container and managed by Kubernetes. So it seems quite easy because everything, we have there's a community project named OpenStack Helm, which already packages the OpenStack services as a Helm chart, and you can easily install it on your Kubernetes environment. But however, during the full migration, we do meet some very important and critical issues, and especially in these 3 areas like performance, troubleshooting, logging, and high availability. So I will go through the performance quickly, and the other 2 of my colleagues will go through the other remaining stuff. So this is the first round of test results of Rally. We can check when we have the first container-based control plane. We see a lot of performance degradations. So if you go through like the Nova boot server, we can see the time used in the new container-based control plane is about 4 times than the first one, than the virtual machine one. So what happened? So let's check what changed during this migration. So first of all, we know we are moving from VM to containers, and the base OS is also changed. We used to use Ubuntu, and now we use Photon OS, which is VMware self-maintained Linux. And we also know the OpenStack version is changed. We are moving from Queens to STEM, and the parameters may also change. So let's go through all the performance from bottom to the up. We check VM performance for CPU, memory, for disk. We check database performance. We check all the CPU memories, compare all the OpenStack parameters, and we also check the upstream versions to see if there is any differences between upstreams. So here's our findings. We are using the wrong Photon OS image, so it caused some disk performance issues. And we are tuning all the parameters to meet our original via 5 parameters. We are scaling out some specific services to work around the bottleneck. And we also find some upstream degradations. Like for Keystone, we notified a very significant performance change degradations. So what can we? Some quick takeaways is that when we are doing to migrate things, don't mix 2 things together. The first one, we changed the upstream versions, and we also changed our underlying infrastructure from VM to Kubernetes. These 2 things, it's hard to tell which one brings the issues. And we need to check the key performance of the key components like MariaDB, Keystone. And the last one is during our testing, because everything is on the new infrastructure, the build, our self-product stability is also an issue. Yeah. Okay, so next one, my colleague Xiaoting will go through the troubleshooting part.
Hi, I will talk about troubleshooting monitor. Sorry. I will talk about logging, monitor, and troubleshooting. In VIO 5.x and before, our OpenStack control panel is based VM based. So if we want to view logs, we should log on all the VMs and assess the log. It's very painful. For VIO 6.0, our central place for all the logs, because they are container based and we will use managed by the Kubernetes. Take one example, kubectl will get all the post information through some operations. For example, if you want to check whether there are some ports in error status, you can use these two command lines. You can easily find out what's the problem here. We also support the integration with our login site. It is one of our VMware project. It will show all the login information through web UI. You can easily check all the OpenStack service status. This is our troubleshooting session. First, in 6.0, when we transfer from to Kubernetes, it will generate all the logs file grouped by the namespace. You can go to the folder and find the information. The next two parts will talk about the troubleshooting parts. One is deploy our OVA. This is our product. You can build the boot sequence log to check whether the Kubernetes status is ready or not. And then you will check the OpenStack cluster status. That is Nova and Cinder, Grounds, etc. You can also view all the configure files for the services. We also leverage some open source smart tool. For example, the kubectl, it will help you grip all the information logs, user regression, and since the same time. For example, we'll run some skill performance tests for a long time, but we can easily see during this time there are some errors, exception, how to view this period logs through all the components. It is easy. Monitor for file and VIO 6, we all use VROps. This is another product in VMware. I will show next. And we'll check the cluster VM and port level metrics. Here is the web UI point of view. First is the class view. It will show all the class status in the Kubernetes. This is VROps. The middle is the node view. It will show all the Kubernetes node status, CPU, disk I/O, some extra. Last is the port view. You will see in this port all the ports information there. At last, we also use the Grafana, Prometheus and Grafana to show all the status for us. It will easier to analyze the status after long run and skill performance test. Oh, okay, other team member Tang Qiang will talk about HA.
Hi everyone. When we're talking about the HA, that always means something is wrong. Besides the traditional failure, VM and host failure, now we have the container failure, which coming in the VL6. Let me share you two cases here when the VL6 was still under the deployment process. The first one, the scenario is we have 4 hosts under the management cluster with their HA enabled. And the VL deployment was run with the HA mode. And this time, the mean power of one host, which with one controller node. And the target controller node should be auto-level migrate to the other healthy host by the vSphere HA function. But since we have something issues here, first, when we checked the services, we found the RabbitMQ and the OpenStack components are in abnormal status. And the connection between the OpenStack components and the MariaDB was lost. And the RabbitMQ cluster is partitioned, as you see here. Each RabbitMQ node thinks he is the master. And actually, there is 3 nodes in the RabbitMQ cluster, but only 1 alive on each pod. So when we debugging this, we found this issue was caused by the pod IP changed during the new pod created when HA happens. And the MariaDB ingress and the nginx config file was not auto-updated with the latest new IP address. Then we fixed this issue by two steps. First, we roll back the MariaDB ingress version to the older one. And then we enhance the dynamic resource changes in the nginx conf files to sync up with the latest changes. So from this case, we know we must take care of the dynamic resource changes during all the pods, such as the containers on the container scenarios. And the second is latest is not always the best choice for us. Here is the case 2. Also, the valve is running under HA mode. We have 3 controller nodes. Then the main power off one of the controller node, and it should be auto-restarted by our cloud provider. Then do it again, another controller node power off, and it will be auto-restarted. Then we run the WordPress application to verify the OpenStack function works or not, and then we found the WordPress failed. There are so many errors like the mount unfed server timeout from the Nova VSPC service. When we debugging that, we found first we lost the boot sequence control of the controller for the LCD and the MariaDB ingress, and for the multi-writer disk scenarios, which attach to all the controller VMs as a shared storage option for the VSPC. We found this is not a good solution for us, and since the guest OS without having a cluster file system support. So the data on the share pods may get corrupt when there's a huge data coming in. So we fix this by reorder the boot sequence to enhance make sure the etc LCD boot up behind the MariaDB ingress is up. And finally, we use the node pod instead of the NFS or the multi-writer solution to create a stable, unique pod for each VSPC service in Nova Compute service. From this case, we know we must make sure we have all the control for the boot sequence order for the pods with dependency. And we should find a good solution when we need to do multi-writer data scenarios between the VMs. Okay, that's all for my share. Thank you.
So this is a context for us. So in case you have any issues, problems, or any suggestions, just feel free to send them emails to us. Yeah.
Thank you.